In this video, I will try to give you a brief overview over information content or self-information, a bit about the information theory backgrounds it has, just so you can better understand what the information flow plugin actually does and to better interpret the data readings of the plugin. So, for information content, let's say given we have an event X. This event already happened in the past, so we know the outcome of the event. But what we actually want to know is what is the information content of that event. So what is information content? So what actual information did we gain by learning about that event X? The information content is usually abbreviated as just I of X, so the information content of that certain event. I'll try to give you an example. Let's say we have a weather forecast. We have the nicest, bright and sunniest weather today, and now we're learning about the weather forecast for tomorrow. In this example, we pretty much have two options. Either it can be sunny as well, or it can be all rainy and murky and bad weather. So what is the information content of each information? So let's say we're opening the newspaper in the morning, the sun is shining outside, and we see the forecast for tomorrow is also sunny and sunny, and the sun is shining, it's warm and nice weather. Since the probability of that happening, it's sunny today, it might be sunny, or the forecast is sunny for tomorrow, the probability of X of the forecast being equal or similar to today's weather is fairly high. On the other hand, the probability of the forecast being completely different and the weather changing very fast is, well, at least a bit lower than tends to stay constant. What information do we get from that, from reading the newspaper's forecast? Well, we kind of expect the weather to stay the same, so we could say that the information content of reading about the same weather tomorrow is, well, fairly low. On the other hand, if we read about the weather being completely different tomorrow, then that is actually quite newsworthy to us. So the information content of that forecast is very high. Now let's add a little math to it, and I will promise you there's not all that much math to it, and you don't really have to understand it to understand the concept. So the information content of an event is defined as the logarithm of 1 divided by the probability of that event. And if you take a look at the example before that, if you have high probability, it means this function results in a very low value. On the other hand, if we have very low probability, then the information content is very high. So that formula seems to work pretty well for us. Now, what does this mean in terms of user interaction? Let's say we have an interaction or an event, as we previously called it, of X. What we now want to know is, what did we learn from observing that X? So what is the actual information content of that X? And the idea behind it is, we're not really that much interested in predictable behavior or interaction that are very common or predictable. We're much more interested in interactions that kind of break a common pattern or are just not as expected as other interactions, and thus have a very high information content. To compute the information content of some interaction x, we just use the formula. So I of x is the logarithm of 1 divided by the probability of that event taking place. Now we could just solve that formula, but the one thing is that we actually need is this p of x. We don't have it yet, but we have to get it somewhere. So this is the next step we did with the plugin. So we have to find and formulate a stochastic model that we can then use to evaluate the probability of whatever user input we get in the system. And we model that by using so-called Markov chains. To be more specific, it's discrete time, discrete space Markov chains, but that's just a detail. And these Markov chains can give us the answer to the question, what's the probability of a certain event taking place, or taking place in the past? Now, the basics about Markov chains. Markov chain is a rather simple and very practical stochastic model. You can visualize a Markov chain just simply as a graph. It has nodes. You just have to start somewhere, and each event triggers one transition in the graph. So let's say we start somewhere at a state, so this is a stateful model, and then an event takes place, some event. And let's say that this event is going from here to here. Oops. But we could also have read another event that would have taken us here. And from there we could go to here, and here, and so on. And the thing is in Markov chain that these transitions have different probabilities. So we can then say we're in this state right now. We received a certain value x, and then we just take a look at the edges and see what's the corresponding edge for this symbol x, and then we just read off the probability of that edge. Let's say we have 1/4 probability here and 3/4 probability here, and let's say this edge corresponds to being the A button and this is the B button. So if that user input, in this case, if the user input is then, for example, the B button, we actually know that the probability of x equal B being in that certain state to start with is exactly 3/4. So this gives us a very nice way to actually do the math on the probability. But now the question is how do we get these? Where are we getting the Markov chain from that we're then using to compute our probabilities? How can we assume the probabilities on the edges and so on? Well, that's also a fairly straightforward approach we're using. And I will also try to illustrate it with a little example. Let's say we just consider D-pad input. So it's just a 4-way directional pad. And we also have a center. So whatever the input could be, it could be left, up, down, center, right, left, 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 and so on. I guess you get the idea. So that's left, up, down, right, and center in the middle. If you want to model that with a Markov chain, this would correspond to a very simple graph with just 5 nodes. And you can go from every node to every other node. So this is a fully connected graph, and you can travel in any direction you want. To make it easy, let's say we start in the middle. So we're in the middle, and also they also have a little loop to it as well. So you can also always go back as well to each node. for sake of completion. So, if we are here, let's say we are in the center, and we're reading the left symbol. So this is where we start, and we're now reading the left symbol, which means we'd go from here to here, to left. So what's the probability here? Well, in the beginning, we don't really actually know. So we have to somehow train the Markov chain to then give us the probability afterwards. But how do we train the Markov chain? The simplest way to just train that Markov chain is just by counting the number of previous transitions in here. So let's say we start out here and we use that sequence to actually train our Markov chain. So we start in the center, and then we go left, and we just add 1 to that edge. Now we're left, now we're going up, we're going from here to, well, actually it's directly to here, we're going down, we're going to the center again, we're going right, we're going left, and then we're going 2 times left. And we would usually do that for a lot of samples to get more robust and more stable data. But once we actually have that, we can now say, for example, let's say we are here. We are at the right node, and then we go left. So the probability of x equals left, because left is the next node we reach, given that x, the previous x, so kind of our state is right, is what? This is just all the edges counted together, how many times we visited that, divided by that number. In this case, it is fairly easy because we've only been here once and there's only been one transition out of it, so the probability in this case is just 1. But if, let's say we are, let's take another color. Let's say we are here in the left node. So the probability, get the colors right. The probability of x, let's say we want to go back to the center maybe. Probability of x being c, kind of the event that we read is going back to the center, given that we are already in the left node, is, we had 1 there, so that is 1 divided by the number of outgoing edges, which is 1, 2, 3, 4, which is 0.25. So that's pretty much a very simple Markov chain model. And what we do in the plugin is that when we have a sequence of data, like before, up, down, left, left, right, left, down, up, center, 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 and so on. We start training somewhere, and then we keep training. And we're also doing evaluation and training at the same time. But then at a certain, if you came far enough, we then also start to remove these last bits again. So we're just using a certain window of data for our training. Or to more precise, we always use the last n samples. And these n samples is usually is taken by time, so it's 15 seconds, 30 seconds, 60 seconds, whatever. That's the options you have in the window length. So we use that data to train a model, and then we gradually start to forget about these before. But the model only represents the last n seconds of data that we saw. And if we then use the Markov chain, the Markov model, to actually evaluate every event, then we get what you see. Then we get what we see in the graph, these squiggly lines of information content that is based on the probability of our Markov chain. That's it for now. There's a lot more on Wikipedia. There's also very good YouTube videos explaining the basics of information theory, also about self-information and that. So if you want to know more about that, just search the web. There's a lot of information there. It might not always be that accessible, especially Wikipedia can be a bit math heavy in the beginning, but it's I guess it's a fairly approachable topic.